In today's video, we'll be solving 40 Jamb questions. 40 Jamb questions on bonding, hybridization, shape of molecules, equilibrium, chemistry of elements, and also acid, base, and salt. And please, I want to inform you that we have a Telegram page, and the link to that Telegram page is in the description below. You just click on the link and it will take you to the Telegram page. We are building a big family, just beyond UTME. We are building a family that can be of help even in your higher institution. If you have difficult topic, you can let us know. You can send the questions, we answer your questions. And you can also reach me on WhatsApp through this number. This is my number. That's +23462655976. So we are building a large family. You can also reach me and I will also be able to attend to you. And please, if you have not subscribed to this channel, we have a lot for you on this channel. Please just hit the subscription button and also hit the notification button so that you get notified when we release very important questions. Okay, so let's just dive in right into the video of today. Question number 1 says that large equilibrium constant for a reaction implies that A, the equilibrium position shifts to the right, B, the equilibrium position shifts to the left, C, catalyst is used for the reaction, D, the reaction is exothermic. When you see that large equilibrium constant is obtained for the reaction, it means that more product is formed, which means that the equilibrium position shifts to the right, or the forward reaction is favored. So when you have an equilibrium reaction, you have reactants on the left and you have the product on the right. So when they say reaction position shift to the right, that means to the right side, it means that more product is formed. It means that the forward reaction is favored. Question number 2 says that if an equilibrium reaction has delta H less than 0, the reaction will proceed favorably in the forward reaction at what? Low temperature, high temperature, or pressure, high volume. Now, when you hear a reaction is having delta H less than 0, it means that it is an exothermic reaction. That means it is an delta H is negative, which means exothermic reaction. And if a reaction is an exothermic reaction, it's a reaction that is liberating heat, giving heat to the environment. And if a reaction is giving out heat in the forward reaction, it doesn't make sense to increase temperature again. What makes sense is to lower the temperature. So when the reaction is exothermic, it will go favorably in the forward reaction at low temperature. Question number 3. Consider the reaction 2A equals 2B, equals to B plus C, delta H is positive. Which of the following changes will favor the formation of the product? Now, A, decrease in temperature, B, increase in pressure, C, increase in temperature, D, decrease in volume. So because this reaction is endothermic, it will go favorably. This endothermic is a reaction that absorbs heat from the environment. It's a reaction that needs heat. So if you want to favor it in that direction, you will need to increase temperature. You need to increase temperature. Now, will pressure have effect on this reaction? No. An increase in pressure will favor the side with lower mole of gases. Pressure is inversely proportional to volume according to Boyle's law. Volume is directly proportional to the numbers of moles according to Avogadro's law. If you bring the two of them together, you say that pressure is inversely proportional to the numbers of moles. Okay, so it means that the side with higher mole of gases will be favored by lower pressure since they are inverse, and the side with higher mole of higher mole of gases, the side with higher mole of gases will be favored by lower pressure. And the side with lower mole of gases will be favored by higher pressure or increase in pressure. But when the mole of gases on both sides are equal, pressure will not have effect. Whether you increase pressure or you decrease pressure, it will not have effect. For this gas, for this reaction, here is 1 mole plus 1 mole of gases, making total of 2 moles. And here is 2 moles. So when you look at the total at that, you see that the mole of gases are equal. Therefore, pressure will not have effect. Okay. So now we've gotten the answer. This is not a question based on pressure factor, it's on temperature. And so we have picked the right answer because the reaction is endothermic. Increase in pressure will favor it. Increase in temperature will favor it. Question number 4. And consider the exothermic reaction. Exothermic reaction. If the temperature of the reaction is reduced from 600 to 300 degrees C and no other condition takes place, then of course, this is the exothermic reaction. Decreasing the temperature will favor the forward reaction. That's very nice. So it means that the concentration of SO3 will increase. Increase in pressure, increase in temperature will favor endothermic reaction, whereas decrease in temperature will favor exothermic reaction. It's just quite very simple. Question number 5. In the reaction above, an increase in pressure will favor the side with lower mole of gas, because here is higher pressure. You go and look for the side with lower mole of gas. When you look at this side, here is 1 mole plus 1 mole, making a total of 2 moles of gases. Here is 1 mole. So 1 mole here. So it means that this answer, increase in pressure, will favor this backward reaction. We favor the reactant side. We shift the equilibrium position to the left, the side of PCl5, which means an increase in the yield of PCl5. All right. Question number 6. What condition favors the formation of the product for the endothermic reaction? So here is the side of the product. A, decrease in pressure, C, decrease in volume, and increase in temperature, a constant volume. No temperature there, okay? So we are talking about pressure. Now, this side is having 1 mole, this side is having 2 mole, and we have to favor this side. This side is having higher pressure. Because it's having a higher pressure, you are going to decrease pressure. It's having higher mole of gas. I'm sorry for that. This side, this product side that we are asked to favor, has higher mole of gas. Because it's having higher mole of gas, you will decrease pressure. That's why option A will be the correct answer. Because the product side is having higher mole of gas, it will be favored by lower pressure. Question number 7. Interatomic combination involves A, neutrons in the nucleus only, B, protons in the nucleus only, C, electrons in the outer shell only, D, electron in the shell. So the correct answer to that is electron in the outer shell only. Bonding, which is interatomic combination, that means you bring in 2 different atoms together. So bonding involves electron in the outermost shell. That's option C is the correct answer. Question number 8. Which of the following is not a characteristic property of ionic compound? A, solubility in polar solvent. B, low melting point. You just know that is the correct answer. Ionic compounds usually have high melting point and high boiling point also. Question number 9 says that which of the following, the compound with the highest ionic character among the following is what? PCl5, CCl4, BCl3, CSCl. Now you know that option D is the correct answer because cesium is a metal, chlorine is a non-metal. When a metal and a non-metal form bond, you will expect ionic character. All these non-metals is equivalent compound. Non-metal, non-metal. Carbon is a non-metal, chlorine is a non-metal to form covalent bonding. Boron is a non-metal, chlorine is a non-metal, they form covalent bonding. So the one with the highest character is the one between a metal and a non-metal. The type of bonds in ammonium chloride is or are what? Now, whenever you hear ammonium salt, ammonium chloride, ammonium nitrate, ammonium sulfate, the types of bonding that exist between them are going to be covalent, dative, and electrovalent bonding. The dative bonding is formed because of NH4 plus Cl minus. When two opposite ion, cation and anion form bond, is going to be ionic or electrovalent. A unique bond is also known as electrovalent. Now, NH4 plus is formed from NH3 and H plus. So that is dative bonding. And ammonia is formed between nitrogen and hydrogen. Two of them are non-metal. That is covalent bonding. Okay. So that is why we have the three types of bonding in ammonium salts. Question number 11. Which of the following types of bonding does not produce a compound? The correct answer is metallic bonding. Metallic bonding only exists in a metal. Can you see this one now? This ion and this ion form ionic bonding. They form ammonium chloride. Ammonium chloride is entirely different from this and this. So this one also, this one, and this one are entirely different from this in dative bonding. But metallic bonding exists in a metal only, that is calcium. In calcium, the metallic bonding is a bonding between a metal cation and its surrounding electron. Okay, so this one like this is actually existing by calcium 2 plus surrounded with 2 electrons. So that is that. So the type of bonding between this calcium 2 plus and this surrounding electron is metallic bonding. So it is not involving other atoms. That's why it does not produce a new substance. Okay. Question number 12. The electronegativity difference between element P and Q is 3.0. The likely type of bond between them is what? Now, when the electronegativity difference is greater or equals to 1.8, it is going to be ionic bond. When it is between 0.5 to 1.7, that is going to be a polar covalent bond, polar covalent bond. But when it is less than 0.5, when it's less than 0.5, that's going to be a pure covalent bond. So for our question, because this is greater than 1.8, it is going to be an ionic bond. When ammonia and hydrogen ion bond together to form ammonium ion, the type of bond is what? As I explained earlier, is a dative or coordinate covalent bonding. So ammonium, this NH4 formed from NH3 and H plus is what? Is coordinate covalent bonding, because the 2 electrons required for forming a bond is donated by the ammonia. That is dative bonding. Question number 14. The shape of ammonia is what? So the shape of ammonia is pyramidal, is trigonal pyramidal. I have a slide here for you. I'm going to just teach you hybridization and shape of molecule within 3 minutes. So with that, you'll be able to understand hybridization and shape of molecules. Now, to determine the hybridization of molecules, what you need to do is to calculate the total pairs of electron in that molecule. Sorry, I may use more than 3 minutes to explain both hybridization and shape of molecules. Okay, now, when you see a molecule, for instance, ammonia, you want to determine the hybridization of ammonia. So what you need to do is you ask yourself, nitrogen is in group 5. And so we have 5 in the outermost electron. We have 5 in the outermost shell rather. So here is one hydrogen forming a bond. Here is another hydrogen. Here is an hydrogen. So we have this. We have this. We have this. So here we have this. Okay. So well, now when you look at this, how many pair? Here is a bond pair, bond pair, bond pair, because they form nitrogen form bond with hydrogen. So 1, 2, 3. Here is a lone pair, one lone pair. Okay, because these two electrons, they did not form bond with other elements, so they are called lone pairs. So, but you calculate the total pairs, 1, 2, 3, 4. When the total pair is 4, it is going to be sp3. One will be on s orbital, one pair of electron will be on s orbital, then the 3 will be the remaining 3 bond pairs. So this one will be here, these two will be here, this one will be here, and this one will be here. So ammonia will be sp3. Now, what about something like SF6? Sulfur is in group 6. 1, 2, so it will have 6 outermost electron. So 1, 2, 3, 4, 5, 6. So fluorine comes, another 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 fluorine comes. So 1, 2, 3, 4, 5, 6. So that is 6 bond pair. Now, because it is 6 bond pair, the total pair of electron is 6. And so it's going to be sp3d2. Okay, now let me give another example. Now look at SF4, for instance, SF4. Now we have sulfur, which is in group 6. It will have 6 outermost electron. 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 4. So here is 1 bond pair, bond pair, bond pair. This one, they are lonely, so they will come together and they will form lone pair of electron. So you count everything together, 1, 2, 3, 4, 5. So it's having 5 total pairs of electrons, and so it's going to be an sp3d hybridized, sp3d hybridized molecule. All right. Now, carbon does not, you cannot use this type of calculation to do for carbon. Carbon is dependent on bond, double bond. When a carbon molecule, a particular carbon does not have any double bond, it's going to be sp3. When it is having one double bond bonded to it, it's going to be sp2. When it is having two, it's having something like the triple bond, is going to be sp. So here is 1 pi bond, here is 2 pi bond. Or when it is like this, when the carbon is like this, like in the case of CO2, this carbon, this one, and this one are also the same. So it's going to be sp. So for instance, the hybridization of CO2 is sp. sp because it is having something similar to triple bond. This is CO2. All right. So it's something having two pi bond, one pi bond from here, one pi bond from here. So it's going to be sp. So carbon molecules have their own like different because they depends on the presence of pi bond. Okay. So, but for a molecule, other molecules from other atoms, you just need to calculate the total pairs. Once you know the total pairs of that molecule, then you will know the hybridization. All right. So all these molecules that they have a total pair, this one, this one, this one, this one, water, they are going to be sp3 hybridized. Is that taken now? Now, for you to know shape of molecules, you just know the total pair in that molecule, and then you know the number of lone pairs of electron. Now, when the total pairs of a molecule is 4 and it's having one lone pair of electron, then it's going to be trigonal pyramidal, like in the case of ammonia. Now, like in the case of water, water is having a total pair of 4, but 2 lone pairs. And because of that, it's going to be bent, or you call it angular, or you call it V-shape. So that is that. Let me show you that of the water. Okay, just a minute. Let me clean this place. Here is water. You have oxygen is a group 6 element. It will have 6 electrons in the outermost shell. 1, 2, 3, 4, 5, 6. So here we have hydrogen. Here we have hydrogen. Okay. So this one form bond pairs. So these ones will form lone pairs of electron. So now when you count everything, 1, 2, 3, 4. So it's having 4 total pairs of electrons. It's going to be sp3 hybridized. Okay. Now the total pair of electron is 4, but it's having 2 lone pair of electrons. So it's going to be a bent molecule. It will fall to this category. All right. So SF4 is having 5 total pair of electron, but 1 lone pair. And so it's going to fall into this category. So once you know this, L, TB, T, TB, then you know this one, TS, TL, and so on, then you can be able to memorize this table and be able to solve problems on shape of molecules. I believe that is very, very simple. All right, so let's go back to the question. So therefore, so now the shape of ammonia is going to be what? Trigonal pyramidal. Now, but you need to also understand that this trigonal pyramidal is a distorted tetrahedral molecule. If you do not see trigonal pyramidal in your answer, in your options, then it's a tetrahedral molecule. H2O is V-shaped, right? Or bent or angular, but it is having a total pair of 4. When the molecule is having a total pair of 4, is tetrahedral. But this bent is a distorted tetrahedral shape because it has 2 lone pairs of electron. Okay, so if you see in your questions, you did not see trigonal pyramidal, then you pick trigonal, you pick tetrahedral. But once the 2 of them are in the option, they are asking you for the actual shape due to the lone pair of electron. So please put that to mind. Okay. So, but when the 2 options are in the answer, the options, the 2 answers are in the option, you go for the actual shape, which is trigonal pyramidal, which is the distorted shape. All right. Now, question number 15 say, which of the following shows hybridization, sp2 hybridization? Okay. Now, let's do that in a jiffy. As we explained earlier, for CH4, CH4, you are talking about carbon, which has 4 atmos electron, okay? And here is hydrogen, 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 hydrogen. So here, 1, 2, 3, 4. So, and that is what? 4 total pairs of electron is going to be sp3. BCl2, boron is in group 2. So then here is chlorine, here is chlorine. So that's going to be 2, which is sp. Now, when you talk about PCl5, you do that. PCl5, here is 5, having 5 atmos electron in the atom share. Here is 5 chlorine. Then it's going to be 10. 10 divided by 2. That means you pair them into 2. It's going to be 5 total pairs, which is going to be sp3d. When you do this one, it's going to be sp3d2. So option D is the correct answer. I believe that is very simple. The shape of CO2, H2O, and CH4 respectively are what? Now, know the shape of CO2 is linear. Ammonia, which is sp hybridized, is linear. Water is going to be bent or V-shape or angular, and it is sp3 hybridized. CH4 is sp3 hybridized and is also tetrahedral. Is a perfect tetrahedral molecule. Are you getting it? So here, this one is a perfect tetrahedral molecule. Water is a distorted tetrahedral molecule, which is bent. So here is linear, bent, and tetrahedral. So please put that to mind. These four molecules are very likely in Jamb question. The shape of ammonia, which is pyramidal, that's trigonal pyramidal. The shape of water, which is bent or V-shape, tetrahedral, linear. The 4 of them, you should be expecting them in your UTME. Question number 17. The type of bonding found in this compound is what? So that is going to be dative bonding or coordinate covalent bonding. All right. So that's why option C will be the correct answer. When you see these types of molecules, you should know that it's dative or coordinate covalent bonding. Which of the following is obtained if chlorine is passed through hot sodium hydroxide? That's going to, you need to know that either through cold or hot, the reaction of chlorine with cold NOH is going to give you sodium isochlorate. Now, but when it is with hot NOH, you need to know that. That's going to give you sodium triisochlorate 5. So that's going to be option A, sodium triisochlorate 5. So please put that to mind. The product obtained when chlorine is passed through freshly prepared calcium hydroxide, that's cold calcium hydroxide, that's going to give you something like this. And that is a what you call bleaching powder. That's bleaching powder. Question number 20. The gas obtained when ammonia is passed through hot copper oxide, copper 2 oxide. So it's going to be what? Nitrogen. So when ammonia is passed through hot copper 2 oxide, it's going to give you nitrogen plus water and plus copper. So you balance the equation. So option D is the correct answer. Question number 21 says, which of the following gases can be collected by the method of downward delivery method? Gases collected by downward delivery method or upward displacement of air must be, heavier or denser than air. And so, air is having approximately 29 gram per mole, okay? And so, because chlorine is denser than air, because chlorine is denser than air, is having 71 grams per mole. Therefore, it will be collected by downward delivery method, which is option C, chlorine. Ammonia is collected by upward delivery method, downward displacement of air, because it's the what is less denser than air. So this is a very common question in UTME. Please don't miss it. Which of the following gases can be collected by downward delivery method? It is chlorine. The one collected by upward delivery method, the popular one, is ammonia. Is that taken? Question number 22 says that zinc oxide is A, basic oxide, B, acidic oxide, C, amphoteric oxide, D, neutral oxide. So we know that zinc oxide is amphoteric oxide. You know, Zalt. Zinc, aluminum, lead, and tin, they will form amphoteric oxide. All right, the amphoteric metals. So the oxides can react with both acid and base to form salts. That is why we call them amphoteric oxide. So acidic oxide, you'll be talking about majorly CO2, SO2, SO3, NO2. Neutral oxide, you talk about CO, you talk about NO. So those are the most common neutral oxide. N2O is also neutral oxide. All right. Question number 23 says that this one reacting with this to give this in the reaction. This one is the what? Conjugate base, acid, base, conjugate acid. Now, when you look at this one, it lost electron. This one lost electron to produce this. Of course, this one is an acid. This one is an electron donor. Proton donor. Donate proton to this one. So it has lost one proton. So this is acid. So acid will produce conjugate base. So this one is the conjugate base. Now, because this one lost H, that's why you know that it is acid. This one gain or accept H to form this, H plus rather. So to form this. The one that gain or that accept H plus is base. The one that lost or that donate H plus is acid. So acid will form conjugate base. So that's why option A will be the correct answer. Brass and bronze are both metallic alloys. Which of the following constituent is common to both of them? Now, you remember that brass is made from copper and tin, and zinc, while this one is made of copper and tin. Okay? So, the one that is common to both of them is copper. Which of the following gases may not be dried using concentrated sulfuric acid? Now, that is ammonia. Ammonia and H2S, hydrogen sulfide, they cannot be dried using sulfuric acid. Please put that to mind. Question number 26 says that which of the following compounds will form a solution if exposed to air? The compound that will form solution when exposed to air is going to be deliquescent. Deliquescent substances or deliquescent compounds will form solution when exposed to air. An example of those solutions, are the hydroxides of group 1, sodium hydroxide, potassium hydroxide, the chlorides of group 2, that the calcium chloride, magnesium chlorides, then iron 3 chloride. Though iron is not in group 2, so but also deliquescent. So these 5 substances, when you see them, you know that they will form solution when exposed to air. So this one will be a fluorescent. This one is hygroscopic. This one, sodium nitrate, copper oxide, copper sulfate, H2SO4. These ones are hygroscopic. They are hygroscopic. These ones are hygroscopic, while this one, calcium chloride, is deliquescent, will form solution one when exposed to air. But this one, they will absorb water from air, but they cannot form solution. They are hygroscopic, but deliquescent will form solution. So question number 27 says that a solid X, when heated, gives off a brown gas. If X is soluble in excess sodium hydroxide, but insoluble in ammonium hydroxide, so then X is what? Now, when you look at it, the one that will form a brown gas gives us a brown gas. The brown gas must be NO2. So you definitely know that A cannot be answer, and also C cannot be the answer. So it will be between lead 2 nitrate or zinc 2 nitrate. All right. Now, but lead and zinc. Zinc, as I said earlier, zinc, aluminum, lead, zinc, the four of them, they will what? They will react with they are soluble in excess sodium hydroxide. Okay, I'm sorry, that's why this lead and zinc, they are soluble in excess sodium hydroxide. But what we differentiate them is that zinc is the only one that is soluble. Zinc, aluminum, tin, they are not soluble in excess ammonium hydroxide. So therefore, zinc is going to be the correct answer. I'm sorry. The one that is insoluble in I'm sorry about that. Let me read the question again. So we already know that this one and this one will not produce NO2, right? Then the question says that the one that is soluble in excess sodium hydroxide, but insoluble in excess ammonium hydroxide. So this zinc is insoluble, lead is insoluble in excess ammonia. Aluminum too, aluminum ion, tin, they are not soluble in excess ammonium hydroxide. Okay, so therefore option B is the correct answer. But if they say the one soluble in excess ammonia, you will have picked option D. I hope that is very, very simple. Now, before I solve the last phase of questions, I would like to share something with you. I want to counsel you against fear. The UTME exam is fast approaching, and maybe other exams you may be having, they are fast approaching. I want to tell you something in the book of Psalm 23, verse 4. Say, yea, though I walk through the valley of the shadow of death, I will fear no evil, for thou art with me, thy rod and thy staff comfort me. You can see someone says that if I go through the valley of the shadows of death, if I go through difficulties, I will not fear. Your UTME is not even the valley of the shadow of death. But I'm sorry for saying that, because I don't know, maybe your parent has told you that if you fail this Jamb exam, forget about it. I'm not sponsoring you again. And so because of that, you are so afraid that, this year Jamb, I must not fail it. I must not fail it. You are afraid. And it seems that you are not still getting a lot of things. But please, don't be afraid. Be conscious that God will help you this time. If you are afraid, God will be disappointed that you don't trust him. When you're talking about fear, let me tell you something about fear. Fear is feeble emotions, arresting reward. You can say that fear is forgetting everything, and run. Some people will just be like, should I run out of this exam? No, don't run. Don't be afraid. Or should I run out of this house so that I will not write the UTME? No, please. That is fear. Fear is feeble emotion arresting all reward, the reward of all the labors you have been putting into preparation for this exam. Don't permit fear. Always remember this verse of the Bible, 2 Timothy chapter 1, verse 20. For God hath not given us the spirit of fear, but of power, of love, and of sound mind. For God hath not given me the spirit of fear, but of power and of love and of a sound mind. If there's only one person that will pass this UTME exam, I will be that only one person. I cannot fail. Tell yourself over and over, God has not given me the spirit of fear. And you will overcome, you will succeed. Say it to yourself, this UTME exam, be jumping. Even if you have not read so much, you have not got so much, you are going to the exam, tell yourself you cannot fail. Those days, I was working, and yet preparing for UTME. Where I was working in school, where I was teaching, I had to tell them, I used to close by around 6 p.m. But 1 week to Jamb, I had to tell them, please, I'll be closing by 4. I think around 4 too. But, but I still did excellently well in the exam because I tell myself, I will not be afraid. Don't be afraid. God is by your side. If you have not given your life to Jesus, give your life to Jesus. Be a child of God. Let God know that you belong to him, that you love him. Give your life to Jesus. He will never fail you. I pray that Lord Jesus, as men that have heard this word, help them to succeed in this exam. Give them success. Help them. They will not fail. In Jesus' name, I pray. Anyone that sin has still captivated going to sin, Lord, I pray that is making the hand of God to depart from his or her life. Oh, Lord, I pray that you forgive him sin and give him repentance from sin. In Jesus' name, I pray. Amen. This exam, you will succeed by the grace of God. In Jesus' name. Amen. Question about 28 says that which of the following noble gases is used in gas-filled electric lamp? If you have watched my previous video, I told you that krypton is used in aerodrome light. Helium is used in filling balloons, and neon is used in combination with other types of light to provide visibility for pilots. But argon, which is a common gas in the air, argon is the noble gas that is found in the air. I told you that the noble gas that is found in the air is argon. So argon is used to make electric lights. So argon is very common in the air, and it is the gas. In fact, argon is the only noble gas that is found in the atmosphere. So it is used to fill electric lamp. It's very cheap, okay? So it's not expensive. So option A is the answer. Number 29 says that which of the following born in air to give a green color in a non-luminous flame? So the one that will give a green-blue color is copper. Copper is the correct answer. So calcium will give a brick red. Please, this is a very common question in Jamb. So calcium will give a brick red. Calcium will give brick red. Sodium will give golden yellow. Golden yellow. Golden yellow flame. Potassium will give lilac. Potassium will give lilac. Lilac. So the one that will give a green color is copper. All right. Now, question number 30 says that which of the following compare an atom to solar system? Rutherford, Bohr, J.J. Thomson, Dalton. Rutherford, which discovered nucleus. Rutherford discovered nucleus, and it was the one that gave us this planetary model of the atom. He compared the atom to a solar system. That is Ernest Rutherford. J.J. Thomson, he discovered the cathode ray experiment, which was later known as the electron. So Rutherford was the one that compared atom to solar system. Question number 31 says that the maximum number of electrons in the subshell depend on what quantum number? It is the azimuthal quantum number. The azimuthal quantum number gives us the number of electrons that is present in the subshell. The subshell is known as orbital. Orbital is the region in the atom where an electron can probably be located. That is also known as subshell. And orbital is a region in the atom where an electron can probably be located. And so the azimuthal quantum number L equals to 0 is the s orbital. The s orbital. When L equals to 0, when the value of the azimuthal quantum number equals to 0, we're talking about s orbital. So if it is equals to 1, we are talking about d orbital. When it's equals to 2, we are talking about p orbital. Sorry, when L equals to 1, it is p orbital rather. Sorry about that. So when the azimuthal quantum number is 1, it is p orbital. It is p orbital. When the azimuthal number equals to 1, it is p orbital. When it's equals to 2, that is a d orbital. When it is 3, that is f orbital. F orbital. So the azimuthal quantum number, tells us about the orbitals, the shape of the orbitals too. So that is the work of the azimuthal quantum number. The principal quantum number, it divides the atom into energy levels or into shells, which is defined as energy level, the KLMN shell. That is the work of the principal quantum number. It gives us the volume or the size of the atom, or it gives us the distance of electron from the nucleus. So, but the one that divides the shells into subshell, known as orbital, is the azimuthal quantum number. Question number 32 says that an electron described by the quantum number n equals to 4, that's principal quantum number 4, L equals to 3 can be located in what orbital? So when n equals to 4, that's the shell number 4, and L equals to 3, that is f orbital. So it's going to be 4f orbital, 4f. So when you see, notice your configuration, this one is the principal quantum number. What you are seeing here, these PS are from the azimuthal quantum number. So option A is the answer to this. Question number 33 says that how many protons, neutron, and electron are in this ion? Now, you looking at this ion, so when you see something like this place is the proton number or the atomic number. This one, 50 is the atomic number. 119 is the mass number. So the number of proton, which is the atomic number, is 50. Now, the mass number is what? Is 119. 50 minus 119 is 69, which is will be equal to the neutron number. Since the mass number is made up of the proton plus neutron number, so the neutron number will be 69. Now, how many electrons are there? For a neutral atom, for zinc like this that does not have plus or minus, it is the number of proton is equal to the number of electron when it is neutral like this. But the moment it carries charge of +2, it means it has lost 2 electrons. So 50 before, but now losing 2 electrons means that it's going to be 48 electrons. So the electrons will be 48, the neutrons will be 69, and the proton will be 50. So which one is the answer? That's going to be option what? Option D. That's option D. Who performed the oil drop experiment? Who performed the oil drop experiment? Now, these questions can be asked in 2 different ways, and I want you to please score it if it comes out in your exam. Now, sometimes they can ask you that the oil drop experiment leads to what? It leads to the determination of a charge of electron. It was J.J. Thomson that determined charge to mass ratio. But this oil drop experiment lead to the discovery of charge of electron. And from the combination of Millikan, and it was Millikan that performed that oil drop experiment. The oil drop experiment that leads to discovery of charge of electron was performed by R.A. Millikan, Robert Millikan. And the combination of R.A. Millikan and J.J. Thomson led to the calculation of mass of electron. All right, so Please, if you have not subscribed to this channel, I want to really plead with you to kindly support this channel by subscribing. We have a lot of interesting videos for you. And between now and Wednesday, I'm going to be uploading mock exams, 40 likely questions. I'm going to upload 2 videos in that regard. So subscribe so that you don't miss any video. And this channel, we are there for you. Just as I said, you can contact us. You can join the channel, the Telegram page for more conversation. All right, let me continue. The ability of an atom to, a molecule to attract shared electron to itself is what? Electronegativity. Electronegativity is the ability of an atom to attract shared electron to itself. Question number 36 says that calcium hydroxide plus ammonium chloride is giving us what? Now, you know that any moment ammonium salt to react with a base, an hydroxide, the gas that must be given off is ammonia. So X is ammonia. That is the laboratory preparation of ammonia. Which of the following is hygroscopic? So I told you earlier that iron 3 chloride, magnesium chloride, calcium chloride, sodium hydroxide, potassium hydroxide, they are deliquescent. So sodium nitrate is hygroscopic, and copper oxide, copper sulfate, H2SO4, all of them are hygroscopic substance. The type of salt that produces 3 different ions in solution is what? So now you're talking about the salt that produce 3 ions. That is double salt. Double salt will produce 2 cations and 1 anion. They can ask you in your exam that double salt will produce how many cations? It is 2 cations and 1 anion. So the type of salt that produces 3 different types of ion is the what? Is the double salt. Question number 39 says that how many ions will be produced from a solution of potassium aluminum tetrasulfate 6? That is, this one, potassium ion will be produced, aluminum ion will be produced, sulfate ion will be produced. And that is an example, because it's an example of double salt. Option A is the correct answer. Which of the following is not a weak base? Ammonia, magnesium hydroxide, copper hydroxide, barium hydroxide. Many of you may argue with the answer I'm going to give here. You may think that magnesium hydroxide is not a weak base. Magnesium hydroxide is even weaker than ammonia. Because it is not soluble in aqueous solution. It's not readily soluble. It has a very low solubility. So magnesium hydroxide is going to be a very weak base than ammonia and even than copper hydroxide. So barium hydroxide is actually the answer. When you look at metal hydroxide, the basicity increases down the group. Now, for instance, I have sodium hydroxide, potassium hydroxide, cesium hydroxide. Now, the cesium hydroxide, which is lower in the group, will be a beta base. Now, so barium hydroxide in group 2 is the most basic because it's down the group. And so it is not a weak base. It's a stronger base. Barium hydroxide is a stronger base than calcium hydroxide. So you are comparing between them. You see that barium hydroxide is a stronger base than calcium hydroxide. I know you have gained a lot in this video. Please subscribe, give like this video. Thank you so much for watching to the end. Yeah, so please share it with your friends, with your bucket mate, with your slippers mate, with your course mate, or with all your mateable mates. Share these videos with them. Share it with your siblings writing WAEC and UTME. And I'm very sure that this video will be of massive help. Thank you very much. God bless you.